Thank you for attending the Ingenu webinar, Making Sense of Your IoT Connectivity Options. My name is Kirsten Garvin, and I'm the Senior Marketing Manager at Ingenu, and I will be serving as moderator. Following our presentation today, we will conduct a brief question and answer period, so please submit your questions during the webinar through the Questions tab on your webinar interface. We've also attached a follow-up document for you to access through the Handouts tab. With me today is our presenter, Dr. Michael Vidomski, Ingenu's Principal Data Scientist. Dr. Vidomski is an expert on machine learning, analytics, and predictive modeling. His role at Ingenu is creating technical engineering content and making it understandable and consumable by our customers and partners. Dr. Vidomski has a PhD in machine learning and analytics, a master's in risk and decision analysis, as well as a bachelor's degree in economics. Now I would like to turn the webinar over to Dr. Vidomski.
Thanks, Kirsten. Appreciate that. Welcome, everyone, to our webinar. We're super excited about it today. We hope that by the end of this, you will have a lot of decision criteria that you can take back and make sense of your connectivity options. We know there are quite a few, and so pay attention and jot down any notes you can get. We'll also have this for your later use, and by the end of this, you will have a set of principles and ideas that you can simplify your decision-making process with. Alrighty, so a little bit about us. We are Ingenu. We've been around, formerly On-Ramp Wireless, just in case you're wondering, and we've been around for about 7 years now. We're headquartered in San Diego, but we do have a small contingent over in Arizona and around the world. We have about 100 employees, and some of those are in other countries. We're in about 21 countries and have a presence in 5 continents. We were founded by the developers, or some of the developers, of CDMA, which is the technology that helped really get the cellular industry going, and took that technology, took all the weaknesses of it, and made it into strengths for machine connectivity, and it's called RPMA, which is supported by about 32 unique patents. We're pretty proud of the leadership we have in our company with names like Andrew Viterbi. If you aren't sure who Andrew Viterbi is, Google his last name, and you'll see a lot of really fun things show up. We also have Ivan Seidenberg, who is the first CEO of Verizon when it was founded, and he also happened to lead the company up until he retired just a few years ago. Richard Lynch was the CTO of Verizon Communications, and John Horn is a pioneer in the M2M industry. And so you see that we have quite a bit of experience in the wireless industry and who have backed us up and given us their advice, as well as provide leadership for our company. And you can also see our key customers, some of the partners that we have, and those who we like to serve and who have used our technology. We're very proud of our relationships with them, and are pleased with the way that we are able to provide key wireless technology for their devices and for their utilities and other things that they do. Alrighty, so the Internet of Things and its landscape. Right here we have a bit of information that describes what kind of devices actually are demanding a connection. What sort of data do they need? And you'll see that 76% use less than a megabyte. So 76% of devices that exist today need less than 1 megabyte of data per month. 86% less than 3 megabytes a month. So that contrasts really, really strongly with that top 4% that need greater than 10 megabytes. So that top 4% is things like videos, video streaming, large data usage applications, and that kind of thing, right? So the needs of that upper top 4% and that lower 86% and others are vastly different, and that has really strong implications for the kind of connectivity that these devices will need. Right? So these lower devices, this lower 86%, they send lots of small messages, and these upper ones send fewer very large messages. So you can see right there that there's already a large difference in how those messages are being sent and the way that they're being received. And so the technologies that address these things should also be able to address those differences. That's important because it'll also have implications on how well they can serve your devices. So remember this figure and understand that the kind of connectivity that you're probably going to need is going to be vastly different from the kind that you're accustomed to when you use your cell phone or some other high data usage device. Alrighty, so how do we make sense of the options? What are some ways we can think about it? What are some questions we can ask? And how can we approach this decision in a way that makes it simpler and makes it so that you can answer the questions in a principled way? Because there are a lot of options to look at. So first thing to realize is that most of these things are really infrastructure-based. They're long-term assets, right? So you want to look for solution longevity. You want the solution, the wireless solution, to last as long as the actual asset itself, the device itself, or the asset that device is serving, right? So we think about network longevity versus sunsetting. You want your devices to be able to sit on the network without really having to touch them for as long as possible, right? Sunsetting is something that is expected and it has a purpose. Sunsetting is often, you hear about the 2G sunsets and that kind of thing, and it's because spectrum is expensive and it gets refarmed or reused to higher data usage, which is appropriate, right? Higher data usage purposes bring in more revenue for cellular companies, and it just makes sense economically for them to do that. Any good business person would make the same decision. But that's not good necessarily for your business or your devices, because your devices on this, when they're connected to wireless, they don't need a lot of data, right? We already know that 86% use that less than 3 megabytes. And so they need a connectivity option that will actually provide the type of connectivity that they need and that will be there for a long time. All right, so make sure your network is machine focused and that it will always be machine focused so that your devices have priority and that they aren't shoved behind, say, human usage or human needs as opposed to the machine needs. All right, so then you want to talk about or think about scalability. And this is important because if the fundamental technology that your network is built on isn't able to grow as it's supposed to grow, as the Internet of Things grows, then eventually, if let's suppose you're on this network and it no longer is able to scale, but you want to add more devices, you're now going to have a fractured presence in the Internet of Things. Part of your devices will be on one network, part on another. And this is really important because access points, they can cover a certain number of endpoints, but not all technologies, as you add more access points, can keep covering more endpoints because they might interfere with one another. And that's a detail that's important. It's called transit power control. And while that's a little down in the weeds, it's important to understand because that will have a drastic impact on your business if all of a sudden your network can't serve the endpoints you have on there. And it's also important because we hear a lot about the size of the Internet of Things. There are lots of different estimates for how large, what size of numbers will be actually on the Internet of Things, 20 billion devices by 2020. If the network technology simply fundamentally cannot support that scale, it's probably not a good place for you to go with your devices because you want to make sure that the solution, the wireless solution that you're using, is going to survive and thrive into the future. But solution longevity doesn't just mean network longevity. It also means device design, right? Can the device on that kind of wireless connectivity, can the battery for that device last as long as it needs to, right? Does the battery life equal the device lifetime? And is the kind of technology being used on that network, is it designed with intelligent battery usage? In other words, is the wireless protocol one that actually is designed to maintain battery life for as long as possible? Another important part of understanding, thing that you should understand when looking at the different options is coverage. So coverage is often talked about in terms of line of sight range. The line of sight range, while it's an interesting thing to think about, it doesn't really capture a real world experience with a wireless connectivity option. So we're going to tell a little story that hopefully will highlight this for everybody. So you think about your Wi-Fi at home or at work, and you're sitting on your laptop and you're working and everything's great, and then you move to a different room, whether it's a conference room or maybe your bedroom or something, and all of a sudden you have a download that started in one room, you go to the next room and it's taking 5 times as long or even longer. Maybe you don't even have signal at all, right? Well, contrast that with this little fact. So Wi-Fi can have a line of sight range of 237 miles. That seems like a kind of silly number, but it's true, right? You can actually close a connection in Wi-Fi from 237 miles away. It sounds pretty phenomenal. Why in the world don't we just all use Wi-Fi and just be done with it, right? Well, that doesn't actually express your everyday experience with Wi-Fi, does it? And so this same sort of analogy can be used for the wireless connectivity for your devices. just because it has a line of sight range of 237 miles doesn't mean it's going to have coverage in your area and coverage with good, reliable connection, right? So it's the area covered and the reliability that matters. And reliability is just the probability that a message is going to get through when you need it to. So when you're thinking about coverage, when you talk to different providers about coverage, think about coverage in terms of the area covered and the reliability of that coverage. If a company, a provider isn't willing to talk about the reliability along with the area covered, you really should suspect it and wonder if it's going to cover your devices. Because as we all know, line of sight range for the Wi-Fi doesn't really express how we experience the Wi-Fi in day-to-day operations. Okay, so thinking about the economics of network deployment. So all costs of a network get passed on to the customer. One of the large ones, in fact, 40% of the cost is the licensing of the spectrum. So providers actually pay to use spectrum, and spectrum can cost quite a bit. Just recently, 20 megahertz of bandwidth was bought or leased for $1.6 billion. That's quite a bit. That's quite a bit. Not the kind of money I have to toss around, right? So of course it's very valuable, and they'll definitely get their money back on that bandwidth. But it just shows you that it costs a lot to try and support licensed spectrum. There's a limited supply, and it also is what leads to the refarming we talked about earlier. It just makes sense that if you've got a certain amount of bandwidth, that you want to use each band for the highest revenue source you can, right? And machines simply don't bring a lot of revenue for many people. They just don't use a lot of bandwidth. And so, of course, human needs drive the refarming forward, and sunsets keep moving forward. So that's just a part of understanding the economics of network deployment. Another thing is the infrastructure costs themselves. So when you build up infrastructure, you have some sort of access point, right? Something that sends out the signal or receives signal. And the area that it can serve is a function of its technology. And so the infrastructure costs reflect largely the ability for that technology to cover an area and also to serve the number of devices that are in that area. So if you have great coverage, then you don't need to build as many access points and throw up as many towers as if you have poor coverage, right? So that savings will get passed on. But it's also the infrastructure cost is a function of capacity per access point. So even if you have good coverage in the area, if the access points you have there can't cover the number of devices that are in that area, you will still need to place more access points there, right? And those costs will get passed on to the customers. Other costs include operational costs. If you have a lot of access points, it costs money to maintain them, to set up the software backhaul, and set up all the other things that are in the back office that are needed to maintain the operation or the actual access points. And the complexity simply increases the cost of the network. So a simpler, smaller network is easier to maintain than a larger, more complex one. Just fewer parts to interact and cause problems for you. So that's important to understand when you're thinking about how much is this going to cost you in the long run, and is it possible that prices could increase in a way that are drastically bad for your company. Alrighty, so full featured value. You want to understand what it is that you're getting for what you're paying. One thing to understand about wireless connectivity is more capacity. In other words, the ability for an access point to send more messages through at the same time means it has more capabilities. The network can actually do more with that wireless signal. And one of the big ones that's been talked about quite a bit lately in the press, and I think rightfully so, is security. Security is what makes sure that the money that you are spending or are thinking about spending on Internet of Things connectivity, device connectivity, is actually going to be protected. We all know that lots of companies have lost money to theft, to hackers, to black hats online. And it's important to understand that if you're going to spend the money to invest in more data because you want more devices connected to your IT and so that you can perform analytics, you should definitely spend the money to make sure that they're secure. and rest assured that the assets that you have spent so much time and energy on are protected from those that would try and do them harm. And the ways you can secure your devices are through things like message confidentiality. That's basically encryption. But it's also important to know that encryption, not all encryption is the same, right? So a 2-byte hash or 4-byte hash or something to encrypt a message can easily be brute forced with a strong enough computer. So you want to make sure you have actually real encryption that garbles up your messages so that people can't understand it when they just look at it. But other parts of security are important and really need to all go together in one nice package, like mutual authentication. Is the endpoint really the endpoint that it claims to be, or is the network really the network that it claims to be to the endpoint? And what about the message itself? Is the message really coming from the device or from the AP that it claims to be coming from? And what about multicast, right? So unicast, so from one device to an endpoint, or from a device to an AP or an AP device, is much different than multicast authentication, right? It's a different beast to have to authenticate between a whole bunch of different devices all at the same time. Another thing is the device anonymous at all stages of deployment? You want to make sure that the ID, or whatever it is that is making it so that you can identify that device, is protected at all times. And then authentic firmware upgrades, which is a huge one, and makes it so that your security can be upgraded by patches and other things, and make sure that your devices are future-proof and can evolve with the security landscape and the vulnerability landscape as the Internet of Things becomes a real thing and moves forward. Other parts of connectivity include two-way communication. All right, so the first sign of intelligence is often communication. All right, so your smart devices need to communicate. It's good that they can talk, but it's also important that they listen. So, do they have true two-way communication? And the simplest form, excuse me, of two-way communication is message acknowledgement. So an endpoint sends a message, and then without message acknowledgement, doesn't actually know if the message was received on the other end. That's a waste of precious battery life, because that means that the device will have to naively repeat the message some number of times without ever knowing if it actually got through, right? So you're wasting not only battery life, but also data, retransmitting the message when there's no message acknowledgement. And the other end of the continuum is, so that's a simple use of two-way communication. The more advanced use is device firmware downloads or over-the-air updates, just like we talked about with security, right? And that allows your devices to be future-proof. Another part of having full-featured connectivity value is flexible frame sizes. So you want to be able to allow the applications to send messages and devices in a way that makes sense for them. And finally, congestion management. This is an important one when lots of devices need to send messages all at the same time. These are called flood events. And one classic flood event is, say, a power outage. Say you have a smart grid that's connected using some wireless technology. And the smart grid all of a sudden goes down. And let's think about the meters, and let's just pretend these meters are wired in, right? So they don't use battery, or they have a battery, but it's more of a backup. And all of those meters all of a sudden want to say, hey, utility company, I am no longer hooked up to power. I am out. Please come fix me, right? So they all send that message all at the same time. Well, if the wireless provider doesn't have congestion management, then those messages will not necessarily get through, or they might get through, but by the time they do get through, it's too late. It could cause could cause the system to fail, right? So the messages don't get through when it matters most. So it's important to have congestion management so that in case of flood events, the messages can get through when they're needed the most. All right. So another way of assessing the value and how well a system actually works is by checking out real-world commercial deployments, because that's really what tells the real story. It's easy to get caught up in hardware specification comparisons, thinking about line items and saying, oh, well, this is this, and you've got that, and that kind of thing. But honestly, they don't tell the real story. Just like comparing line items in a computer, oh, RAM versus RAM, or this, it doesn't. What really tells the story is actually experiencing the system. So treat each option like a black box, right? All you need is a pipe. for your data to flow from your devices back to your IT system. And that's what you need to really understand is, how is that pipe working for you? Does the black box do what you need it to do, and does it do it for a price that is acceptable to you and that you're willing to pay? So if you can, find day-to-day usage of the actual system in real-world situations. How have customers experienced the system in the past? Does it work? Has it worked well? That kind of thing. Poke around, ask for case studies, try and figure out what it would function like for your company. There's a lot of hype. There's a lot of statements. It's really easy. I mean, marketing departments are great, and they do a good job, right? And so you want to make sure that you can understand what's going on, and ask for actual customer experiences, so that you can understand what it's going to be like when it's actually deployed, not just on paper. So you will eventually have to pay for the system or for the connectivity, and you want to make sure you understand, well, how much is it worth, and will it give you a good return on your investment? And calculating that return or estimating that return involves all costs and all the returns that you gain from it, right? So you want to judge by the total cost of ownership over the entire lifetime of the device and of the connectivity, not just a single thing. All right, so we're going to consider the entire service, like the monthly or annual subscription fee, the recurring costs, the cost of the device, any costs that are associated with having to upgrade in the future due to network sunsetting. Thinking about if maybe the connectivity doesn't have security built in, is there some way to tack it on later? It's an added cost. Are there maintenance and repair costs if you have to go out because the battery life isn't great? Go either change the device or do something to it, and of course battery costs as well. So I like to think of this in a way like, if you had to justify why you chose a certain connectivity provider that you did to the CFO, what would you have to explain to them when they come to you with their the cost sheet and say, look, here are all these costs. Why in the world did you choose this one? You want to be able to go back and say, well, I considered all of these different things over the lifetime, and not just this one line item, like say device cost or something else, where it was like, oh, the devices were super cheap, so I got it. And then they look at you and say, well, that's not all that happens to go with this system. So think about the entire cost, the total cost of ownership over the lifetime of the service, to help you understand the value you're getting, right? And it's really, what are you getting for what you're paying? Are you getting everything you need to provide high quality service to your customers if you're an application provider, or if they're your devices, are you getting all the functionality you need for what you're paying? You get what you pay for, and you pay for what you get. So we've talked about a lot, and I hope that everyone's been taking notes. In summary, we have network longevity, right? And the idea here was that most things are infrastructure-based. They're long-term assets. They're things that are going to be out there and you don't want to have to touch for a long time if possible. You also want to choose something that can grow and scale with your company. So can the network actually provide the kind of connectivity that 20 billion, 100 billion devices are going to need into the future? If that technology can't do that, if there really is no feasible way without having to totally redesign the technology to provide that kind of connectivity, then that's not a ship you want to be on when it starts to sink. So make sure that it can actually move forward and grow with your company, and not just with your company. Make sure that it can grow with all the companies that are going to be connecting to that wireless provider. Because if it can't do that, that's only going to be doom and a problem for you later on down the road. So don't kick the can down the road. The other part that we talked about was coverage, and that it really is about stating reliability along with the coverage, right? Without stating the two together, you really should suspect the statement, the coverage statement that's given. The line of sight range, right? Wi-Fi line of sight range, 237 miles, and then you go in the next room, you don't get any connectivity. So that's really not a great way to think about coverage. And full featured value. What are you getting for what you're paying? All the network costs will get passed on to you, and you want to make sure that you're getting a lot of bang for your buck, and just understanding a bit about what's happening on the network and what's happening with the wireless provider will help you understand how those costs could change in the future. And then capacity is what gives your devices capabilities and allow them to perform to their fullest potential. So you don't want to limit your devices and the way that those devices can serve you and your company by choosing a wireless provider that simply can't give you all the features that you need. And one that we talked about that was really important is security. Right? The data, you've already decided, assuming you're investing in some sort of M2M connectivity, you've already decided that the data is valuable, and then it's going to help your company, and it's going to help your customers. So you want to keep that data secure so that it, A, remains your data, and B, doesn't get in the hands of those who shouldn't have it, and C, so that you can rest assured at night and know that you are getting all the value out of that data that you should. Also, the two-way communication is essential. Smart devices need to talk, but they also need to listen, and sending messages blindly or naively without knowing if they were received wastes battery and also wastes capacity. So make sure that you can know if your messages are received, and also have things such as firmware upgrades or over-the-air updates and that kind of thing. That's a pretty advanced feature, but it's one that we've all kind of become accustomed to through our experiences with the human consumer products like cell phones and that kind of thing. And measuring the return of your investment isn't just a single line item cost. It's all the costs that go with the technology, and then also accounting for all the returns. So making sure that you calculate the total cost of ownership over the entire lifetime of the device and of the connectivity. And then real-world commercial deployments will help you understand how the system will function in real life, when it's deployed, when it's out there, when it's actually going. And this does a few things for you. It doesn't just give you an idea of how it's going to function technically, it's also going to give you an idea of how it will be to interact with the company providing the wireless service. All right, you want to know and understand, what is it like to interact with the company? How is it going to be when problems do arise, or something does happen where you need some extra attention, or maybe you don't understand something. Understanding how real customers have interacted with the company will help you know how you'll get, what kind of support you'll get into the future, and how you'll be supported as you try and grow your company and expand your business. So we talked about quite a bit today, and obviously we are a wireless connectivity provider. We're Ingenu, simply genius. We have deeper and wider coverage than basically every wireless provider that we're aware of in the IoT space, and we can support that coverage with unparalleled network longevity. We can offer contractual agreements 20+ years that our technology will be backward compatible, and we're really proud of that. We also deliver quite a bit of value for connecting your devices and getting on the Internet of Things, and are pleased and to support all the things that we've talked about here. And of course, if you're interested in learning more about our technology or about what we're doing, and we're happy to talk to you, you can reach out to us using info@ingenu.com, or you can give us a call right here, and we're happy to answer a few questions right now.
Okay, thank you, Mike. Now we'll open the webinar up for questions. And for the Q&A session, we're joined by Dr. Ted Myers, who is Ingenu's co-founder and Chief Technology Officer. So the first question that we have is, how is an IoT customer charged for use of the network, such as data, volume, transactions, etc.?
All right, so as far as charging goes, it really depends on what the application is, how often it's being used, and what the data model is for the device and for the application. Generally, the more data you use, obviously, the more you're going to pay. That kind of makes sense. But it really is application specific, and how often you're using the network, what kind of devices you've got on there, and that sort of thing. So it really is data model driven. And so to really understand, if you have devices that you'd like to connect, or if there's something that you want to get connected, we're happy to hook you up with our business development team, and they can work with you on finding the price that makes sense for the kind of data that you need and the devices that you want to get connected. So please reach out to us, and we can talk more specifics that way.
Okay. The next question is, do you have an example of how a system can fail if it isn't prepared for congestion? Ted?
So yeah, that's a very good question. Hello, everybody. Yeah, kind of the one example that pops to mind immediately is something that happened in 2011. In our backyard, we have a fairly big investor-owned utility, and maybe some of you may have been impacted by the big Southern California power outage. Basically, we also have a system covering, a pretty big region of that same utility. So what happened is that, that power outage actually did what Mike started to describe, caused the, electric meters deployed in this area, which wasn't, RPMA technology, caused the system to kind of come down. And so as a result, the system, the communications wasn't restored for 72 hours after the power was restored. So that kind of gives you a feel for, if some systems, mesh in particular, for this example, is poorly impacted, but it can be down, it can fall over very hard and for very long periods of time. And, that 72 hours may be a little bit of an extreme example, but, you can imagine that being, in service when your network is needed the most is a pretty critical value proposition of the connectivity. So by contrast, our system, never went down, so that system was up for the entirety of the power outage and was, in full service at the, resumption of power restoration. So I think that's the one example that pops to mind.
Okay. Another question we have is, what devices are already certified and deployed on the Ingenu network, and what devices are in the pipeline for 2016, and what is the certification process to get those certified on the network?
So yeah, I could take that one. Well, I think, we have quite a few devices in our ecosystem. It's, pushing 30 devices today. We expect that number to, increase dramatically through 2016, as we kind of expand our vertical focus from utility to, the more general public network. In keeping with our name, Ingenu, simply genius, we take great pride in making that integration as simple and as non-obtrusive as possible, so that doesn't put any dampers on the ecosystem that we predict is really going to take off imminently. Okay,
thank you, Ted. This one's probably for you as well, Ted. What role do you see for standards in driving availability of devices to connect on the RPMA network, and where do you think 5G will play?
That's a great question, and I think standards are important. Kind of having a, initial technology that, is on track to become the de facto standard, is kind of the way that we're pursuing it. And I think, ultimately, when it solves the customer's needs and it does so at a price point like Mike was describing, that's very low, that, that really is going to be the overarching consideration. And that's what we've been doing for the last several years, is solving customers' real-world problems. And we're not adverse to standardization at all. And we can, embrace it when it makes sense to our ecosystem.
Okay, this one's a question we get a lot. How does Ingenu's RPMA compare to LoRa and Sigfox?
Oh, great. Okay, so this is one that we do get asked a lot, quite a bit, and we can think about it in a few different ways. I guess we could start with just coverage and then maybe talk about capacity a bit. So as far as coverage goes, if you were to do a direct comparison, say one access point to another, one of our access points can cover an urban area, and it's important to understand it's urban, because even different types of topography or obstructions can change the coverage for a given access point. So urban coverage, so you're in an urban area with, say, greater than 95% reliability. One of our APs can cover about 200 square miles, and that differs depending on how dense that is, but I mean, this is still urban. Whereas based on our estimates, looking at the different specifications and technologies like LoRa and Sigfox, a LoRa access point can cover approximately 13 square miles, and Sigfox about 3 square miles for the same exact kind of urban coverage and the same reliability. And notice we're pinning it to a reliability and the type of topography, right? So let me just say those numbers again, 200, 13, and 3. So it really is orders of magnitude greater in terms of its ability to cover, or I'm talking about RPMA here, is really orders of magnitude greater in terms of its ability to cover an area. And that's not at the same time sacrificing capacity. Generally, you know, there is a trade-off, coverage and capacity. There's somewhat of a trade-off there. But let me then talk about, just to make sure I'm clear, that was in the FCC domains, right? So in America or other FCC compliant areas. Okay, so still in an FCC domain, you think about the uplink and downlink capacity. So one of our APs can support about 41 kbps at it, right? So that's 41,000 bps. A Sigfox AP can support just about 2,000 bps and LoRa about 510 bps uplink. And then if you think about downlink, we can support about 20,000 bps, while Sigfox is about 50 you know, or something like that, and LoRa is roughly the same, right? So we're still talking about 40,000 versus say 2,000. This is a few orders of magnitude difference in capacity, right? All the while still being able to cover many multiples of the area with the same reliability. And so while we're often in the press compared to Sigfox and LoRa in terms of being LPWA, in reality, really are a different beast simply by the nature of the technology that we're using. We can cover such a huge swath of land and also deliver so many messages in that same area. We really kind of think of ourselves as being able to cover that large gap, right, that cellular, it doesn't make much sense for cellular to cover, right, all that 86% of the devices and the data needs. So thanks very much for asking that question.
Okay, another question is, what radio frequency do you use, and what is the typical throughput rate, and how do you handle interference?
So we use the 2.4 gigahertz ISM band, and there are so many great reasons to use that band. We have a white paper on this, so please check out our white paper. We need to release it in the next couple of days. We've got it made, and so we talk about the interference is something that we deal with really well, but going back to the 2.4 gigahertz spectrum and why we use that is because the regulations are really what get in the way of the ability for signals to get out there as opposed to actual physics-based limitations. So like physics-based limitations are things like, you know, is there propagation loss and that kind of thing. And while in the ISM band, 900 megahertz doesn't have quite as bad propagation loss, as soon as you start getting into real-world implementation of a system using 900 megahertz versus a 2.4 gigahertz, there are all sorts of benefits to 2.4 gigahertz band. You can transmit at much higher power. You have 80 megahertz bandwidth around the entire world, so you have an instant global presence. Whereas with 900 or others, you know, it's very spotty. Just try going, you know, across the ocean with a cell phone, and you immediately understand the difference in worldwide coverage versus non. And then you can also transmit for much longer times. Other ISM bands have 400 millisecond transmit time limitations, or they have a 1% duty cycle, which drastically reduces the ability for messages of any heft to be sent across the network. And so that with a bunch of other reasons, is the reason why we picked this 2.4 gigahertz spectrum. Please see our white paper for more details, more detailed and thorough comparison. But as far as how we handle interference, we handle it at 3 different levels, right? We handle it from the network layer, we handle it at the PHY layer, the MAC layer, and we handle it at the physical layer, right? And so from the physical layer, we are able to provide channel coding, which provides quite a bit of redundancy. And at the network layer, we have network congestion, like we talked about today. And on the MAC, we have all sorts of enhancements as well. And Ted, are there any details that you want to add to the interference, just to make sure there's no salient point that might help make it clear?
Yeah, I think that was, you know, well laid out. Like, I guess, you know, kind of the one thing maybe I could offer is that, you know, like, and this is kind of keeping within the philosophy of, hey, what does the system actually do in real world conditions? You know, we've had 38, private networks running for many years now. Interference levels are something that we monitor very closely and understand very well. We're not immune to the laws of physics, so our urban footprint is going to be smaller than our rural footprint based on the hum of a lot of traffic that happens. But when you're talking about like a 200 square mile footprint in rural areas and a 30 square mile footprint over downtown LA, you can imagine that the economics of the density of devices that would exist in these very urban areas and the ability to cover 30 square miles with one piece of infrastructure, even though there is a lot of interference, is kind of testament to how all of those interference mitigations are working together harmoniously at all the different levels of the protocol.
Hey, let me add one more thing as well. Is if you think about the 2.4 gigahertz spectrum, is there are 80 megahertz bandwidth right around the world, and so while Wi-Fi does use some, and there are known areas where there would be more interference, but we only use 1 megahertz channels, right? So we can actually fit very nicely in between very highly congested areas, things that are known to be congested, but we can go right around them. It's like a highway where the lanes where all the big trucks are going to be, and you can easily slide in between them. And so that's one of the ways. There are other ways. We have a white paper on that. Please check it out, and it'll explain in a lot more detail and more thoroughly as well.
Our next question is your technology relevant outside the United States? For example, there's a transmission power limitation in Europe for ISM bands, which affect coverage.
Well, that's a great question. So as you noticed, I did only talk about FCC, but Europe, we still are very, very healthy. So the thing with Europe is we can't transmit quite as strongly. We can't have as much power, but we aren't subject to the same duty cycle limitations, say, as the 900 megahertz band. So where we can't transmit as loud, we can still transmit as long as we need to. And the 900 megahertz band, you just can't do that. And so let's go to the coverage numbers for, say, an ETSI domain. One of our urban devices, or an AP in an urban area with 95% reliability or greater can still cover 94 square miles, while, say, a LoRa or Sigfox are roughly about the same at about 26 square miles. So while the difference isn't nearly as drastic as in the FCC domains like the United States, it's still much more. It's still about 4 times as great. So RPMA can still outperform in terms of coverage about 4 times as great as the LPWA players there. And the same thing with uplink. Our uplink and our downlink are still phenomenal. In Europe, we have an uplink of 20,000 BPS, right? Excuse me. Let me make sure I got this right. So in the Europe areas, we have 20,000 uplink and then about 10,000 downlink, whereas for Sigfox and LoRa, it's still many thousands times less than that. And then for the downlink, the Sigfox one, I think they have like 4 messages that are 8 bytes or something like that in a day. And then LoRa is still about 5. They have 1 channel dedicated. It's like 5 BPS per channel or something. So, I mean, we're still talking about many thousands times greater in terms of capacity, and then coverage, we're still about 4 times greater in terms of coverage. So just the economics of network deployment just makes so much more sense for RPMA than they do for the LPWA providers. I hope that answers your question. If you have more questions, we do have white paper on how RPMA works, and please talk to us. We'd love to talk about it more.
Okay, next question is, would it be fair to say Ingenu's solution is better suited for non-moving assets, such as utility meters, security panels, etc., than mobile assets like vehicles or shipping containers?
Yeah, that's a good question. We got our start, in a lot of stationary assets, but there's nothing fundamental in the technology that keeps us from, supporting mobility. And as a matter of fact, our next system release will support mobility, very well up to vehicular speed. So, kind of these many mobile applications are, we're currently working with partners, even at the vehicular speed to service those needs.
Okay, thank you, Ted. Okay, that's going to be it for the question and answer session. We do have some questions we didn't get to, so we will be answering those questions offline for people. We also encourage you to contact us through the email that we had on the slide deck. And as a reminder, this deck will be sent out to all the participants. Thank you very much for attending the webinar, and we look forward to the next time we meet on the next webinar. Thank you.